Hello, YouTube. This is Mr. Bakari. Today we're going to talk about graphing transformations of sine and cosine. But first, I want to start with the parent graph of sine and cosine. And so we're going to take a look at that right now, and I'm going to show you how we put this together. So up in the top left-hand corner, I've got a unit circle. This unit circle is displaying what we call the quadrantal angles. That is 0 radians, pi over 2, pi, 3 pi over 2, and back around to 2 pi. Okay, those are our angles that lie on the x and y axes. And along with them, I provided the coordinates that go at those angles when we're referring to the unit circle. Remember, in the unit circle, our radius is equal to 1. So if our radius is equal to 1 and sine theta equals y over r and cosine theta equals x over r, well, if radius is just 1, then that's just y over 1 and x over 1. So we can get rid of r when we're talking about the unit circle here. So here we go. Y is sine and x is cosine. And that applies to all the points all the way around. Very convenient. So now let's graph the parent function of sine and cosine. So we're going to start with sine over here. Now remember that on the positive side of the x-axis, this is our initial position. This is where we start measuring angles and where we start graphing. Okay? And as you can see, y is 0 here. So I've put a point at y equals 0 on my graph. Now, as I move to pi over 2, you can see that y has changed to 1. So at pi over 2, I'm going to put a point at 1. And as we move along to pi, y is now back to 0. As we move to 3 pi over 2, y is now negative 1. And as we come back around to start 2 pi, y is back to 0. And if you connect these points, you've got your parent sine graph. Okay, that is one period. Okay, a period is measuring the length of the waveform. So think of it as the length of where the wave starts to where it starts to repeat. Okay, all right, now let's look at cosine's parent graph. So cosine, as you can see at 0 radians, starts at 1, so it starts up high. And then as we move around, cosine goes to 0 at pi over 2. It goes to negative 1 at pi. As we approach 3 pi over 2, x is 0. And as we come back around to 2 pi, x is 1. So if we connect those, you can see our cosine graph. Okay? Now those are our parent functions, and that's where we begin. So now we will look at some transformations and we'll talk about that. So for our first example, we have a cosine function. And what I like to do is I have my students collect some information first before we move to the graph. That is the period, the amplitude, the steps, and the start. Okay, so we talked about the period. The period of sine and cosine is 2 pi. Okay, so from where it starts to where it starts to repeat, one rotation, 2 pi. That goes for sine and cosine. The only thing that's going to change that is a horizontal stretch or compression, which we refer to in trigonometry as a period change. We will get to those in the next video, but for today, we're just looking at those transformations that do not include a period change, okay? The amplitude is the height of the waveform, okay? So it's basically the distance between the midline and the high line and the midline and the low line. So what do I mean by that? Well, we have these imaginary lines. We've got a midline, and our midline on the parent function starts at 0, okay? The midline is going to be shifted with a vertical shift. So in this transformation up here, you can see that our graph has been shifted up 1. So I'm going to take my midline and I'm going to shift it up 1. Again, your midline represents your vertical shift. The high line and the low line represent the amplitude. So when I'm talking about amplitude, I'm talking about how high from the midline to the high line and from the midline to the low line. Okay? Now, we're going to label these to the left. My midline is at 1 because I've been shifted up 1. And the distance from the midline to the high line is 2, as you can see right here. That's our amplitude. That's our A value, our vertical stretch or our compression. Okay? And that same distance from the midline to the low line would be 2 as well. So that's what I'm representing with these numbers here. I like to write those on the left so they're not buried with the graph over here. Okay? So now that we've established that, the amplitude is 2 right here. Okay? Now, steps, we take our period and we divide our period into 4 steps. So we divide our period by 4. So 2 pi divided by 4 is pi over 2. Okay? Steps are the increments that you measure off on the x-axis that represent our angles. Okay? Where we start is x equals 0 on every graph, unless there is a horizontal shift. So in this function, we have a shift, if you look in parentheses, to the left, 3 pi over 2. Okay? So now I've collected this information. I've got my midline, again, which is my vertical shift, my high and my low, which represent the amplitude. Okay? The distance between here and the distance between here and here is the amplitude. All right, so now I'm ready to start labeling my x-axis. So my starting point is negative 3 pi over 2. So I'm going to put that right here. Keep in mind some spatial reasoning here. And I'm going to step pi over 2. So if I move one step to the right, pi over 2, I'm now at pi. What I like to do is keep a common denominator. And if I jump another pi over 2, I'm at negative pi over 2. One more brings me to 0, and another one brings me to positive pi over 2. So that's 1, 2, 3, 4 steps, and 4 steps make up a period because we took the period and we divided it by 4. Okay? So on this example, we're going to graph one period of cosine. We start at negative 3 pi over 2. Now cosine, as you remember in the parent function, starts up high. Okay? So we're going to start up high, move to the midline, low, mid, and back to where we started. You'll always end up back to where you started if you are graphing a full period. Okay, then we'll connect the dots, and we've got our cosine graph. Okay, I always like to circle the starting point so we know what we're looking at. This is a cosine graph. It's been shifted left 3 pi over 2. It's been shifted up 1. The amplitude is 2, as you can see here, and we are done. Okay, so that's how it's done. Now let's look at another example, look at a sine graph. Okay, we're going to go through the same steps. The period of sine is 2 pi. Okay, again, cosine and sine, the period is 2 pi unless there is a horizontal stretch or compression in which you would divide 2 pi by b. Okay, we'll get to that in the next video. This one does not have a horizontal stretch or compression. The amplitude remains 1 because as you can see, our A value is 1. And the steps, again, we're going to divide period by 4, which is just going to be pi over 2. Okay? Our starting point is our horizontal shift, which moves us to the right pi. Okay? Now, I like to make a common denominator between my step and my start. It just helps labeling the x-axis very simple, especially when these get really wacky. Okay, so I'm just going to write pi as 2 pi over 2, which is equivalent to pi. Okay, now let's bring in our midline. The midline, again, starts at 0, but it has been shifted up 1. This represents our vertical shift. Okay, our high line and our low line are the amplitude from the midline. So if our amplitude is 1, we're just going to go up 1 and down 1. Okay? We want to remember to label these somewhere. I like to label them over here on the left. That is 0, y equals 1, and y equals 2. Okay? This shows me my vertical shift and my amplitude. All right, now I'm going to label the x-axis. So I'm going to start at 2 pi over 2, okay, which is pi, and I'm going to move in steps of pi over 2. So if this is pi, and I'm graphing a period to the right, you can graph a period to the left, you can do both, okay? That's teacher discretion. So for this example, I'm going to do a period to the right. I'm going to move one step, pi over 2, which is going to put me at 3 pi over 2. Another step, 4 pi over 2. Another step, 5 pi over 2. And my last step, 6 pi over 2. Now, if I'm graphing a period, how do I know when to stop? That's 4 steps. Okay? Now, this is a sine graph. Sine starts in the middle. Okay? So, if sine starts in the middle, I'm going to start right here. Now, typically, if we follow the unit circle, we start at 0, we go to 1, we go back to 0, we go to -1. But as you can see up here, we've got a reflection. Okay, this is a reflection over the x-axis. So what that means is instead of going up from the midline, we're going to go down. We're going to flip this. Okay, connect the dots here. And that is one period of sine. I'm going to circle my starting point. And now why don't we just go ahead and graph a period to the left? Okay, so if I ask you on a quiz or a test to my students, graph one period to the left of start, one period to the right. Let's see what that looks like. So back to my steps, pi over 2. Another step to the left, and I'm at 0. Another step to the left, I'm at negative pi over 2. Another step to the left, I'm at negative 2 pi over 2. Now, have I gone a period? Yes, from my start to here is 2 pi. Okay? So now I'm going to continue my graph for another period, and that's what that'll look like. Okay? So to go over that one more time, my vertical shift up 1 is shown right here on my midline. The amplitude of 1 is shown between the high and the mid and the low. My start shows my horizontal shift moving to the right pi, and I'm showing my reflection by moving down before I go up. Okay? So those are all of my transformations, and I hope that that gives you a good introduction to graphing sine and cosine. Join me in my next video where we will look at some period change transformations. Thank you very much.